Good morning or afternoon. Today in geometry, we're going to be talking about triangles getting started on this unit. So in the idea of using triangles, you already know what triangles are. And a triangle is just a three-sided polygon. Now to go with that, there's classification for triangles. You know these terms. The fact that we can classify them by sides and get isosceles, scalene, and equilateral. Or we can, let me slide that over. We can look at triangles and classify them by their angles, which is acute, obtuse, and right. And there's a special acute one called the equiangular triangle. So you know that part. But we're going to talk about some of those other things that you probably know. We just need to reinforce them a little bit in this presentation. So yes, we can classify triangles by their angles and their sides. And you should be able to do that given any triangle whatsoever. And then you already know that the three angles of a triangle add up to 180. We actually have that as a theorem, angle sum theorem. The sum of the measures of an angle of a triangle is 180 degrees. So if you add up the three angles in a triangle, you get 180 degrees. And there is a proof of this theorem on page 185 in your textbooks. So what does that mean? That means we should be able to take a problem like this and figure out what the measure of angle 1, 2, and 3 is just using that triangle sum theorem. So when I look at it, I got a 47 and 57, and I need to figure out what angle 1 is. Well, if I add 47 and 57 together and I subtract that from 180, I would get the measure of angle 1. Well, 57 and 47 added together is 104, so 180 minus 104, better write that down for you, is 76. So angle 1 is 76 degrees. Well, 1 and 2 are congruent angles because they're vertical angles. That means angle 2 is a 76 degree angle. So now I have a 76 and a 55 degree angle together that need to add up to 180. So I would take 76 plus 55 and subtract it from 180, and that leaves me with a 49 degree angle. So there's how we can use that triangle sum theorem in a nice simple problem they have to deal with. Now, there are also things called corollaries. A corollary is a theorem that follows directly from another theorem. So we can call it a corollary or we can call it a theorem. If it's a corollary, it means it directly follows from another one. So here are some corollaries to the triangle sum theorem. The first is the third angle theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles have to be congruent. So if I know that angle C is congruent to angle D and angle A is congruent to angle F, well, I know B and E have to be the same measure. Why? Because A plus C plus B would have to equal 180, and F plus D plus E would have to equal 180. And if A and F are the same and C and D are the F, well, then I end up with the exact same thing saying A plus C plus B has to equal 80, and A plus C plus E has to equal 180. Subtract off the ACs, and I got them being the same thing. Okay. The next is called I call it the obtuse triangle theorem, and it's because there can only be at most one obtuse angle in a triangle. One. Well, if I have one angle that's more than 90 degrees, I'm not going to be able to have another one in the triangle and still have that up to 180. So that does follow from triangle sum theorem. And then I have what I call a right triangle theorem, and there can be at most one right angle in a triangle. Same reason with the obtuse. Once I have 90 degrees, I can't have another one in there, and it's going to work out. And there is another corollary that's kind of a combination of these two, and it'll say or. You can have at most one obtuse or one right angle in a triangle. And I think that's the way your book calls it. And then there's the acute angles of a right triangle theorem. It's the corollary of the right triangle theorem and the triangle sum theorem. And it says that the acute angles of a right triangle have to be complementary. Well, that makes sense. If I got three angles that add up to 180, and one of them is a right angle, because I can have at most one of them be the right angle, well, the other two must add up to 180. So those are some other theorems, and we call them corollaries because they follow from the triangle sum theorem. Now, in addition to that, here's one of the things we need to really talk about, and it's that each angle of a triangle has an exterior angle. Actually, it has two. So when I look here at my triangle 1, 2, 3, 4, and I extend the sides out, Up here at angle 1, there's two other angles there, that 4 and that 5. The 4 is an exterior angle to angle 1. The 5 is an exterior angle to angle 1. For the angle 2 here, angle 6 and angle 7 are exterior angles. They're outside the triangle. They're a linear pair with an angle inside the triangle. They're made by the extension of the side. So for angle 3, it's angles 8 and 9. They're the exterior angles. Now here's the reason that's important is because we also have interior angles that are remote from these. So when I look at these problems up here and I get rid of the 6 and the 7, and I get rid of the 5 and the 4, I can't get rid of the 5 and the 4. I have the 4 being related to the 2 and the 3. The 4 or the 5, either one of them, is related to that 2 and 3. The 2 and 3 are called remote interior angles from those exterior angles. So when I do have 6 and 7 in there, 1 and 3 are the remote interior angles. So which angle would make the linear pair? The other two angles in the triangle are called remote interior angles. So with that being said, if we did a real quick think process here, down here in this figure at the bottom, right here in the middle, I've got the exterior angle 1. Right beside it inside the triangle would be angle 4. Angle 1 and angle 4 add together to give us 180. Well, we know 2, 3, and 4 add up to give us 180. Well, since they both equal 180, I can let them equal each other. So now I can have angle 1 plus angle 4 has to equal angle 4 plus angle 2 plus angle 3. And I really should have the measures on all of those. Well, they both have a 4 on there. So what does that tell us? I can subtract the 4 off. And now I have that the measure of angle 1 is equal to the other two angles added together. This is a neat little principle. It is called the exterior angle theorem of triangles. The measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. So this angle out here is equal to the angle x and the angle y added together. That's what this theorem says. This is the most underused theorem in geometry by geometry students, because you're going to get a problem that looks like this and you'll think about other things to do with it rather than necessarily going at it that way. So here is similar to the problem you're going to get on your assignment. They want you to find all these angles here that are mentioned. What we know is that angle 4 and angle 5 are equal. That's good to know. So I'm going to put a little mark in here in my figure that those two are equal. So now I need to start figuring out what the measure of each angle is. And we can start anywhere we want, and I suggest we start right here. Angle 6 and the 136 are a linear pair, which means they're supplementary. So I can then just go ahead and take 180 and minus 36, and I get a 44 right here. So there's the 44. Now, here's what would normally happen. People would then say, okay, I'm going to take the 7 and the 47 and the 44. They make a triangle, add them up, they have to equal 180. And yes, we can do that. But that triangle sum theorem just said that the 4 and the 7 added together had to be the 136. So if I just take 136 and I subtract 47, I get my answer of 89. So this is an 89-degree angle. I didn't have to do the whole addition. Now, let's go to the next set. The next set of problems I see are right here. I've got the angle 1, the 69 degrees, the 47 degrees, all equaling a straight line. So that means together they have to add up to 180. So if I take 180 and I subtract 69 and I subtract 47, I get 64 degrees. So angle 1 is 64 degrees. Now we can use it to figure out what angle 2 is by the triangle. So 63, 64, and something have to equal 180. And that something would be a 53-degree angle. So this is 53 degrees. So that leaves us with the triangle at the bottom, the 3, 4, 5 triangle at the bottom. Well, now here's the thing to notice again. Here's a linear pair. So that means we should be able to figure out what the measure of angle 3 is pretty quickly by taking 180 and subtracting 64. And it says that angle right there is 116. Now, the next thing I know is that the 4 and the 5 together are remote interior angles for that 64. I also know that the 4 and the 5 are the same. So if I take 64 and I have two angles that are the same measure, it says really I just have to divide this by 2 to get either one of these two angles. So that means both of these are 32-degree angles. So I have now figured out the measure of every single angle in this figure, and I could answer the questions over there. That's what your assignment is today, is using these theorems to make them work, to figure out different measures within a figure.